Hi everyone, so today we will be looking at this problem which is contiguous array. So first let's read the problem statement. So the problem says that we are given a binary array and we have to return the length of the maximum subarray which has equal number of zeros and ones. So let's say if we take this example, so in this example we can see that the length is 2. Why? Because we can either take this sub array which has a single 1 and a single 0, or we can take this sub array which has again a single 1 and a single 0. If we take a look at this example, so what is going to be the sub array which has equal number of zeros and ones? So this is also one of that subarray which has equal number of zeros and ones, but we are only concerned with the largest subarray. So 2, 3 and this. So yeah, so the largest subarray which has equal number of zeros and ones is this, and the length of that subarray is 6. So now let's try to solve this problem, right? So if we take a look at this example, so what is the longest subarray here? So I think 1, 2, 3, 4. So okay, so I think this is going to be the largest subarray which has 4 zeros and 4 ones. So what is going to be the length of this subarray? It's going to be 8, right? So now let's try to solve this problem, try to think how we can come up with a solution for this. So the very first approach that should come to your mind is maybe a sliding window. So what we can do is we can maintain 2 pointers, left pointer and the right pointer, and what we can do is maybe try to see that. So if let's say this is a generalized solution, so this is your valid window and it consists of left and right pointer. So for the next element, so what we are going to do is we are going to run a loop and try to increase r. So currently our window is this. So for this element we can see that if the addition of this element makes this a valid window or not. So if it does, so what we can do is we can update our length variable, and if it does not, then maybe try to remove this or maybe try to cut from here. But and also, like, what is going to be, how are we going to check that if our window is valid or not? So what we need is we need to count frequency of 1 and frequency of 2. So maybe we can basically keep track of this in a map, and which the map will basically keep track of how many zeros and ones we have come across in our valid window. But this kind of solution is not going to work, because let's say we have this subarray 0, 1, 1, 0, and we have kept left here and right here. So if we include this element, the frequency of 0 is going to be 1, and we are going to increase this. So sorry, if we try and if we include the 0, the frequency of 0 is going to be 1, and right now we have not come across any 1. So this is the single 0 is not going to be a valid window. So what do we do now, right? Whether do we shrink the window or do we increase the window? We have no way of knowing. And if we can come across, like, if we can move forward r here, so it can become 0 and 1. But after that also, once your window has become valid, there's no way for us to know if we should increase r or increase l. So we have no way of knowing that uh, if we increase our window size, we have some more valid windows, and similarly if we shrink our window size by increasing L, we also don't know that if we have lost some elements or not. So what I mean by the second thing is that let's just uh, I mean if we follow the template and simply try to, this was our R, this was our L, and if we simply try to shrink the window by increasing L, and this is also going to be here, so if we shrink our window size to this, then we know for sure that we have lost a solution, because our solution was going to be 0 and 1. So if we shrink the window, we are losing on a solution, and if we do not do that and regardless of that make our R here, then okay, so we have come across this. Now what do we do? So at 0 and like at this position, we have two ways. We can either increase our L and like expand our window, or we can sorry, our L was supposed to be here, right? Or we can increase L and shrink our window, and there is no way of knowing what to do at any given point of time. So we kind of understand that sliding window can't be used here. So what can be used here and what cannot be, and let's see if we can come across something which can like lead us to our solution. So let's try to come up with some other algorithm to solve this question. What was our, okay, let's take another example, who cares. So 0 1 1 0 1 1 1 0. So in this example, this is our largest window or the largest subarray which has equal number of zeros and ones, and so yeah, so we have to find some way of knowing this. So okay, what we can do is since we are concerned with subarrays, we cannot what we can do is we need continuity in our in the subarrays that we generate. So okay, so one thing that we can understand from this is what does equal number of zeros and ones mean. So there are some observations that we need to do. So let's say you have 3 zeros and 3 ones. So one thing that we should understand is that if we try to maintain a prefix sum or even just the sum of the subarray, then we need to understand that only ones will contribute to the sum. So if we have 3 ones and 3 zeros, sum will be 3 and zeros will not contribute anything here. Also this observation is a good starting point, but we cannot base our solution just on this. Why? Because there can be cases where there are 3 ones and there is a single zero, and the sum of that is also going to be 3. There are 3 ones and there are 4 zeros, the sum of that is also going to be 3. There are 3 ones and let's say 2 zeros, the sum of that is also going to be 3. But can we do something about these zeros? which will help us understand or which will help us check if there are equal number of zeros and ones. So that is what we are trying to do. So and another thing that one thing that we can do to kind of guarantee or like kind of guaranteed one thing that we can do to know for sure how many zeros are there is convert these zeros to minus ones. So now let's say we have a subarray which has 3 ones and 3 zeros, and since we have transformed these zeros to minus ones and there are 3 ones, the subarray sum of that subarray will be 0. So now if we have a subarray which has 3 ones, let's say 7 zeros, the subarray sum of that is going to be minus 4, right? In this manner we can know for sure that if after we have transformed our zeros to minus 1, after we have done this, and after that if a subarray sum has the subarray sum equals to 0, then we know for sure that that subarray has equal number of zeros and ones. So this was one of the things that we needed to understand. And how are we now going to solve this problem? So we have this subarray 0 1 1 0 1 1 1, and after transforming this array this array looks like this: minus 1 1 1 minus 1 1 1 and 1. So essentially this problem gets reduced to we have to find the largest subarray which has sum equals to 0, and this happens to be our subarray. And if you have solved the previous problem, subarray sum equals k, then we know how to solve these kind of problems. And let's try to take one more. Let's try to solve this problem again. So we have this array from index I to j, let's say, or let's say start to some given index I. The subarray sum from here till here is x plus k, and if there exists a subarray from index s to, let's say, I, which has sum of k, then the remaining part, the sum of remaining subarray will be k. So this is the idea on which we will base our solution. So what are we going to do is we are going to check in this solution. What are we going to do is we are going to check that what is the sum from index, let's say, I to index j. Let's say the sum is 4. Then what are we trying to check is that if there exists a subarray such that we have 4 minus 0, does there exist a subarray which has sum of 4 minus 0? If there exists a subarray which has sum 4 earlier also, then that means that there also exists a subarray which has length or the sum which has the sum of 0, and this is what we are concerned with, right? So this is basically the heart of our solution. And one more thing that we need to understand is that what do we need? What do we need right now? We need prefix sums, and we need to store our prefix sums such that at every while we are traversing this array and maintaining prefix sums at every given index, we also want to check whether a certain prefix sum exists or not. So we need to find prefix sums in constant times. So maybe we can either use sets or maybe we can also use maps, right? Now we should discuss about whether to use a set or a map. So now what are we concerned with in our question. So let's say 0 1 1 0 1 1 1, and this goes on to -1 -1 1 1 -1 1 1 and 1, right? And let's assume that sum at this point is 5. So we need to know whether there exists a subarray previously which has sum of 5 minus 0. So we can, if there exists a subarray which has sum of this, then we know for sure that the subarray sum from index this till this is 0, right? So what I mean, since we are concerned with length, what we need is we need to keep track of the indexes also, right? So since we need a pair, so we need, what do we need? We need prefix sums and we need the index at which that prefix sum has occurred. So we will be going with the maps. And the last thing that I want to show you is, let's say we have subarray sum of 5, and this is just an arbitrary number I have taken. We will know the exact sum while we are try running this solution. So let's say from index starting till here the subarray sum is 5, but there exists two possible subarrays which have subarray of 5 minus 0. So some subarray sum from index this to this is also 5, and subarray sum from index this to this is also 5. So what does this mean? This means that there exists two subarrays which has sum of 0, this one and this one. And since we are concerned with the longest subarray, what do you think is going to give us the longest subarray? The first one or the last one? Obviously the first one, right? So if we look carefully, what is the difference between these two? So the difference between these two is that prefix sum 5 has occurred here earlier and prefix sum 5 has occurred here after. So what I'm trying to say is that since we are moving from left to right since we are iterating from left to right in our solution, we are just going to track the first occurrence or the first index at which that prefix sum has occurred. Why? Because, give me a minute. Yeah, so why is that? That is because we are only concerned with the largest subarray. So yeah, and another thing that I would want to answer is, why would there occur a situation where there can be subarray sum at index I also, and then later on there can be subarray sum 5 also? That is because we also have negative elements in our array. Remember we had transformed 0 to -1, and that means that there are negative elements in our array, and that means that, let's say if at index 5 at any given index we occur 5, then there are two ones in between and then there are two zeros in between. So subarray sum here becomes 6, here becomes 7, here becomes 6, and here becomes 5 again. So that is why there can occur a situation where, I mean, the prefix sum of 5 can occur at index I and index j, where j can be greater than I, right? So now let's try run this code and dry run this approach, and then we will try to code this solution. So firstly we transform this array. This becomes -1 0 0 -1 1 1 and 1. So what are we going to do is we are going to maintain prefix sum, and then we are also going to keep track of index. So okay, so earlier we have prefix sum and index. So at the starting our prefix sum is 0 and it occurs at index -1. Now our prefix sum is -1, and what did we need? Goal is to find 0, right? So at this index 1 2 3 4 5 6 7, at this index we see that whether -1 minus 0, does -1 occur previously in our array. If it had occurred, then what would it have meant? That from this position till this position our subarray sum is -1. If there had existed a subarray which had -1 as its sum, then that means that from that index till from this index till this index the subarray sum would have been 0. But we can see clearly -1 does not exist, so we move forward. We just write the occurrence where -1 has occurred, right? So -1 has occurred at index 0. Now, did I do something wrong? Yeah, I have written 0 here. This should be 1. So now we now we add 1 to this and our prefix sum becomes 0, and it occurs at an index. So yeah, so now we check that whether 0 minus 0 exists in our array or not, and we see very clearly that 0 has already been so 0 has occurred at index -1. So what does it mean is that from index starting till the index 1 our subarray sum is 0. Or let's say, first of all, let's just erase this array. Okay, so what does this mean is that from index this till this the subarray sum is 0, and from starting also the subarray sum was 0. So this should mean that the sum of these two positions, I mean the sum of this subarray is 0. And is it 0? Yes, it is 0. So what are we going to do is we are going to keep track of a length variable. Initially we will initiate it with 0, and we will see that what is now the length. So the length now is 2, so we'll update the length to 2. And also we, as we have discussed, we are not going to update the index of 0. Why? Because let's say 0 is like from starting, or let me explain here, it will be better, right? So length equals to 2. So from here to here our subarray, from at this position our subarray sum is 0. From here to here our subarray sum is also 0. And let's say there occurs a subarray such that its sum is also 0. So we will have this subarray which has sum 0, and also this subarray which has sum 0. So since we are concerned with the subarray which has the largest length, then what do you think is the subarray which has the largest length? This is this one, right? So if we had updated our length, I mean the index of 0 to this position, then we would have lost this subarray. So since we want to know the maximum length, or since we want to maximize the length, we are not going to update the index. So I hope that part makes sense. So we are not going to update the index. Now if we add 1 here, so the prefix sum becomes 1. Now what are we going to do is we will check from here till here our subarray sum is 1. Does 1 minus 0 exist earlier or not? So we can see it does not exist, but had it existed, our so let's say it had existed at index I, then what would have meant? From here to here the subarray sum is 1, from here to here the subarray sum is also 1. That would have meant that the subarray from length I minus 1 till this position, the sum of that subarray would have been 0, but we can see that 1 minus 0, which is 1, is not present in our prefix map. So we'll update the position of 1. Now if we add minus 1, our prefix sum becomes 0. So we'll check we'll check 0 minus 0, does it exist? Yes, it does. So what does it mean is, from here till this position the subarray sum is 0. From here till here our subarray sum is also 0, but our subarray sum at starting was also 0. So now so we have two subarrays with length 0, with sum 0, this one and this one. So which one are we concerned with, or which one do we want? We want the largest subarray, right? So again, I hope it makes sense, like now it should make sense that why are we not updating the index. So we have not updated the index, and we'll calculate the length, update the length. So let's do here. So from at this position our subarray sum length, our subarray sum was 0. At this position also our subarray sum is 0. So that should mean that the subarray sum from this position to this position should be 0. Is it 0? Minus 1, 1, 1 minus 1. Yes, it is 0. So we'll update this to 4, right? Which is 3 minus the occurrence of this plus 1, right? So yeah. Now again we are not going to update the index. So now if we add 1 here, so our subarray sum becomes our prefix sum becomes 1. Now we are going to check is, what we are going to check is, does 1 minus 0, which is 1, exist in our prefix map or not? It does exist. So what does it mean? It means that from here to this position our subarray sum is 1, and from here to this position our subarray sum is also 1. That should mean that the subarray sum of this subarray is, the sum of this subarray is 0. Is it 0? Yes, it is 0. But what is the length of this subarray? The length is 2, and we have already stored the length. The current maximum length is 4, so we are not going to update it. All right. So yeah, now we move here and add 1, so our prefix sum becomes 2. So what we are going to check is, does 2 minus 0 exist in our map or not? So 2 minus 0 does not exist. Had it existed, so this would have been like, from here to here the subarray sum is 2, from here to here the subarray sum is also 2, then that would have meant that the subarray sum of this subarray is 0, but 2 is not present. Similarly, the subarray sum, okay, I need to expand little bit. No, I don't. Okay, so 1 was present earlier, so we had not updated the index. So the 2 occurs at index 5. Now for this we add 1, so our subarray sum becomes 3, or our prefix sum becomes 3. So we'll again check whether 3 minus 0 exists in our prefix map or not. So it does not. But if there was a subarray with sum 3 earlier, what would have meant? It would have meant that from here to here the subarray sum is 3, and from here to here the subarray sum would have been 3, and that would have meant that the subarray sum from this position to this position would have been 0, right? So yeah, we can see clearly that the 3 does not exist. So we update the position of 3, and once we have iterated this whole array, our answer would have been present here. So yeah, but I hope the part where I have explained why are we not updating the index makes sense, right? So I'll explain it again one more time, and then we will go and try and code the solution. So let's say we have the position. So like initially the sum was 0 here. From this position to this position, at this position your subarray sum is 0, and let's say from this position to this position your subarray sum is also 0, and from this position to this position your subarray sum is also 0, and from this position to this position our subarray sum is also 0. So what would have been the maximum, the largest subarray which has length of 0? The largest subarray would have been from this position till this position, right? And if we had updated the occurrence of 0, then that would have not given us. So what we want is, we want to store the first occurrence. So the sum of this subarray is also 0, this subarray is also 0, and this subarray is also 0. But since we are concerned with the largest subarray, we cannot afford to lose the first occurrence, because if we lose the first occurrence, we will not be able to find the largest subarray. We will find the subarray which has sum 0, but we will not be able to find the largest subarray which has sum 0. Similarly, let's say if we were given find the largest subarray with sum 4, again, let's say from here to here, our subarray sum is 7. In that situation, we would have tried to find out 7 minus 4. So does a subarray exist with sum 3? Let's say there exists two subarray with sum 3. This array has a sum of 3 and this array also has sum of 3. What would have meant was this subarray would have sum of 4 and this subarray would also have sum of 4. But we wanted the largest subarray, right? So this would have been our answer. And this occurs right after, this occurs after the index, like if the prefix sum at this index was 3 and if the prefix sum at this index was 3, so this subarray's starting point would have been just after this, right? So if we had updated this this prefix sum, we would only be able to find this subarray, not this one, right? I hope this makes sense. Now let's try and code the solution. So we will try to find the size of this subarray, and we will also need the length. We'll initiate it with 0. What else did we want? We want a map to track the sum. I'll say this map as m, which will track the prefix sum versus the index or the first occurrence index. And what else did we need? So length and this, right? So now we will be running a loop from 0, and also we need a variable to track the running sum. So, and one more thing we need to understand is that, this is, we have run the loop, right? And think of it is this way. Think of it as like this. So we are not actually going to make any changes to this array. What we are going to do is we try and check that if the element at this position is 0, then we know that it will contribute -1 to the prefix sum and or to the subarray sum, and if the subarray is 1, this will be contributing 1, right? So in this manner we will try to find the sum. Now what do we check? We check that if this sum exists. So what we are trying to do was, we were trying to find sum -0, but sum -0 is sum, right? So what are we going to do is, we are going to check whether this prefix sum exists or not. So if it exists, then we will try to update our length. So how are we going to update it? We will take the maximum of current length and the length of that subarray. So the length of that subarray will be I minus the index of that sum, right? So that is how. And then if it does not exist, what are we going to do? We are going to insert that sum versus index pair in our map, and at the end we are going to return the length. So length sum unordered map, we have not written n here. Length equals to 0, that's -1. Okay, let's try and run the test cases. M dot find is not equals to M dot end. What is M? what is the problem here? Okay, I forgot to write equals to here. Okay, so okay, so we have not inserted the first occurrence of 0. The first occurrence of 0 was happening at index -1, so this is kind of an edge case. Now let's run and see. So all these test cases are passing. Now let's try and submit this solution and see if it is getting accepted or not. Okay, so we see that all the solutions are all the test cases are passing. So now let's try to analyze the time complexity. So what we are doing is we are running a for loop simply. So the time complexity is O of n, and about this place complexity, we are maintaining this unordered map, and in the worst scenario all the prefix sums can be like unique, although that cannot happen, but like if we have an array of 1 1 1 1 1 1 1 1 only, so the prefix sums will be unique, and in that situation our the space complexity will be O of n. So yeah, that was all for this question. I hope it was helpful. So yeah, thank you for watching and keep watching. Thank you.